Good afternoon. Thank you very much for joining us today for the Innovation for Cool Earth Forum 9th Annual Meeting, hosted by the Ministry of Economy, Trade and Industry and New Energy and Industrial Technology Development Organization. Before we start the session, there are some housekeeping announcements for the participants. As a COVID-19 measurement, please always wear your mask and pay attention to general hygiene precautions, such as regular hand washing, hand sanitizing, and proper etiquette when coughing and sneezing. If you're not feeling well, please contact the Secretariat for help. In case of emergency, please follow the instruction of the staff. Now, we would like to start the final session on the side event program, NEDO Green Innovation Fund Project Symposium, a challenge toward global supply chain carbon neutrality. To start the session, Mr. Tanaka Tetsuya, Deputy Director General, Ministry of Economy, Trade and Industry, will give the opening remarks. Mr. Tanaka, if you please.
Thank you very much. Good afternoon, everyone. I'm Tetsuya Tanaka from Ministry of Economy, Trade and Industry, METI, the Japanese government. I'm in charge of industrial technology and green innovation policy in METI. Thank you very much for joining us today in NEDO Symposium about Green Innovation Fund. I'm very pleased to make my opening remarks to everyone here and online. As you probably know, Japan has committed itself to achieving carbon neutrality by 2050. We made this commitment about 6 months before the IEA issued a famous report, the net zero emissions by 2050 scenario. Achieving carbon neutrality by 2050 is not an easy task, of course. We need to drastically change the structure of energy and industrial sectors. Obviously, innovation is a key to success of carbon neutrality by 2050, as IEA pointed out in the report. The Japanese government formulated the Green Growth Strategy in 2020. In order to realize this strategy, the government established a Green Innovation Fund of 2 trillion Japanese yen, approximately $14 billion at NEDO in March 2021. This fund is the largest R&D fund in the government. METI and NEDO manage this fund and financially support R&D activities by mainly companies for the maximum 10 years. There are many projects that the Green Innovation Fund has been supporting. One of the main targets in the fund is to establish global supply chains for alternative fuels such as hydrogen and ammonia, including the development of zero-emission ships. In order to make this happen, international collaboration is crucial. Today, we invite some speakers from the Australian government and foreign companies, and we are hoping to discuss international collaboration and partnerships for carbon neutrality of global supply chains. I would like to close my remarks by expressing my hope that all of you here and online today will have fruitful exchanges of information and ideas at today's symposium. Thank you very much for your kind attention.
Thank you, Mr. Tanaka. Now, I would like to hand over to today's Master of Ceremony, Mr. Kiba of NEDO. Mr. Kiba, if you please.
Thank you for your introduction. Firstly, I would like to express my appreciation to all panelists and audiences who are attending to this session. Due to the global decarbonization movement, it is becoming important for corporate activities to attempt decarbonization for its supply chain. Towards the realization of global supply chain carbon neutrality, innovations in various technology fields as well as integration of these technologies are requested, such as for the construction of alternative fuel supply infrastructure of hydrogen and ammonia, introduction of next-generation mobility, such as zero-emission vessels and aircraft, and the application of GHG reduction technologies. Achieving global supply chain carbon neutrality also requires the cooperation between countries involved in distribution. Therefore, at this event, we invited 10 experts to introduce efforts by the public and private sectors of each country towards the realization of global supply chain carbon neutrality and discuss economic measures and ideal forms of international cooperation to accelerate these efforts. This session is scheduled for 2 hours. In the first half of the session, the moderator will give a 10-minute presentation, and the other panelists will give a 5-minute presentation. Next page, please. After the presentation, there will be a Q&A and discussion for 45 minutes. We also accept questions from audience. Online participants could post their questions through the system. Now, I would like to introduce Professor Hiekata, University of Tokyo, the moderator of this session. Now, Professor Hiekata, if you please.
Thank you for your kind introduction. I'm Kazuo Hiekata, professor at Graduate School of Frontier Sciences, University of Tokyo. And today, I'm really happy to have this opportunity to moderate this session, this great event. And thank you for joining this symposium here and also from online, and maybe overseas and many other countries. We have many distinguished speakers from Japan and also overseas. It's a great, it's really a great opportunity and great event, I think. Then I by myself really loved working on engineering background, but also as for this challenge, carbon neutral challenge, we need to work on the organizational behaviors, like we need to change our society. Then today, this event and the presentations today, it's a great chance for me, and maybe I hope, and for the audiences to understand and know new things. And I'd like to work hard to make new contribution from great presentation today. Thank you very much. Okay, then move on to the presentation.
I'm Kazuo Hiekata, professor at Graduate School of Frontier Sciences, the University of Tokyo. Our graduate school of Frontier Sciences, is designed for problem solving with transdisciplinary approach. We are actively working on carbon neutral topics. Today, I will present my topic titled Model-Based Design of Carbon Neutral Maritime Transportation System. This is the abstract of my presentation. Due to the existing infrastructure and the complexity of the maritime industry, decision makings for new technology adoption and for policy design for decarbonization are very difficult. A framework to discuss the future visions and alternative fuels for decarbonization is proposed. The key concept of the framework is the model-based approach to describe the current practice of maritime transportation system in both qualitative and quantitative manners to predict the uncertain and complex behaviors of the global maritime transportation system. In my presentation, please remind the underlying keywords. Let me explain the framework for model-based approach to design strategy of carbon-neutral maritime transportation system. Our laboratory organizes multiple research topics aligned to this figure. Let me explain the figure in this slide. Left-hand side of the picture are the input of global maritime transportation system. We simplify the input of maritime transportation system, then consider strategy and uncertain environment as the input. Strategy for technology development and policy design drives global maritime transportation system, shown in the lower half in the middle. In the current practice assumed here, our maritime transportation system is driven by the strategy for technology and policy and the exogenous environment, such as market conditions. Then, we will get the outcome of the technology deployment and policy design at the end, as shown in the right. The problem is that the complexity of the maritime transportation system is increasing. Stakeholders independently or sometimes collaboratively make decisions of their business. Elements of the maritime transportation system are tightly or loosely connected. The propagation of the effects by changes in technology and policy is difficult to be predicted. We selected greenhouse gas emissions and economic activities as major metrics of the outcome of our specific strategy. In the right, the two graphs in the right-hand side are one example of the output of the behavior and responses of maritime transportation system for a specific strategy. The decisions, design of strategy of technology development and policy design are very difficult because of the complexity and uncertainties of our global maritime transportation systems. Then, our laboratory proposed a model-based approach to support the decisions of the strategy. The key idea is simple. We introduce digital twin to this framework. We can put our proposed strategy into digital twin, then get the responses as time series data of greenhouse gas emission and economic activities. We should compare the simulation results and actual data and give feedback to decision-making process for strategy. We can explore better strategy to meet our target and evaluate that with quantitative outcomes. At the end, let me focus on the right-hand graph. As I mentioned, these are the time series prediction results of greenhouse gas emissions and economic activities. For the short range, without fields, infrastructure, political or societal changes, data-driven approach is helpful for the predictions. However, the predictions for long-term, including transitions of energy carriers, are more difficult. We need to discuss the modeling of mechanisms and assumptions defined here. To utilize the results of the simulation or data-driven predictions, the result must be explainable. So, we think that visualization is also important for this research topic. This figure overall explains the key idea of maritime transportation system with intelligent adaptive mechanism. And this is a proposed research topic of our laboratory as well. We are developing simulators in our several research projects. Discrete simulation for calculating carbon dioxide emissions and modeling of shipping companies as multi-agent are typical examples. We conducted several workshop sessions for researchers, professionals, and general public. These are the pictures in an academic conference held at MIT in July. We are exploring how we can make impact on the decarbonization of the global maritime transportation systems. We are not yet well utilizing workshop sessions, so we are very happy to receive your feedbacks. This is a list of a related textbook and handbook and our design cases in publications. Please look at them if you are interested in. I hope this presentation contributes to the decarbonization of maritime transportation. Thank you very much for your attention.
Professor Fiekata, thank you for your impressive presentation and remarks. Now we move to the next speaker, Dr. Imura. Dr. Imura is Director General, Green Innovation Fund Project Coordination Office, NEDO. Now, Dr. Imura, please.
Good afternoon, distinguished guests and everyone. My name is Imura Akiko, and I'm the Director General of NEDO. As the Secretariat of the ICEF, I also thank all the panelists who have joined this event. I hope we'll have a fruitful discussion. Now, I'll speak on my topic, Japan's NEDO Green Innovation Fund project toward achieving carbon neutrality by 2050. As Tanaka-san and Mehdi introduced, in October 2020, the government of Japan formulated action plans under the Green Growth Strategy. Under this strategy, the government of Japan created a 2 trillion yen fund in March 2021 for NEDO, aiming to provide continuous support for R&D, demonstration, and social implementation projects for 10 years to companies that commit to ambitious goals. This slide and the next one show the areas of the 17 projects implemented through this fund. The projects enclosed in red, that is hydrogen supply chain, hydrogen production, fuel ammonia supply chain, hydrogen aircraft, and zero-emission ship are the typical projects that contribute to global supply chain carbon neutrality. In the following slides, I will show you more details of these 5 projects. The first project is Next Generation Ship Development. However, this project will be explained by the next speaker, Tamura-san of the Ministry of Land, Infrastructure, Transport and Tourism. The second project is Next Generation Aircraft Development. To realize carbon neutrality in the aviation field, realizing a sustainable aviation fuel or SAF, as well as innovations such as aircraft weight reduction, engine efficiency improvement, and electrification, hydrogen aircraft development, etc. are necessary. Entire aircraft development is conducted by OEM manufacturers such as Boeing and Airbus. Japan will develop core technologies for hydrogen aircraft as well as technologies for lightweight primary structural components with complex shapes for them. The third project is large-scale hydrogen supply chain establishment. This project will promote the construction of a large-scale hydrogen supply chain as well as demand creation. Using multiple hydrogen carriers, The project aims to reducing the supply cost to 30 yen per normal cubic meter in 2030 and 20 yen per normal cubic meter or lesser in 2050 by the development and demonstration of large-scale transportation equipment and hydrogen combustion stability and actual hydrogen power generation equipment. Next project is hydrogen production through water electrolysis using power from renewables to establish domestic hydrogen production bases that utilize surplus renewables. This project aims to further reduce equipment costs by increasing the size and modularizing multiple types of water electrolyzers, implementing membranes, and demonstrating power-to-X systems. The last project is field ammonia supply chain establishment. Ammonia supply is limited to raw materials such as fertilizers. Therefore, building a large-scale field ammonia supply chain integrating use and supply sites is necessary. We will develop and demonstrate a manufacturing method for field ammonia that can achieve large-scale production, cost reduction, and CO2 emissions reduction. We'll also develop technologies for high mixed and single firing. Working together with the government of Japan as well as the implementing entities, NEDO will contribute to the realization of carbon neutrality by 2050 via the acceleration of the social implementation of the R&D outcomes of this fund. Thank you very much.
Dr. Imura, thank you for your presentation. Now, we will move to the next presentation. Mr. Tamura. Mr. Tamura is the Director, Ocean Development and Environmental Policy Division, Maritime Bureau, Ministry of Land, Infrastructure, Transport and Tourism, Government of Japan. Now, the next presentation, please.
Hello, everyone. Firstly, I would like to thank for all people arranging this great event. I'm Tamura Akihiro, engaging in environmental policy and technology policy of maritime area. GHG emission reduction from international shipping is an important global issue in the light of its volume of GHG emissions and its international characteristics of this sector. In my short presentation, I would like to briefly introduce overview of GHG emissions from international shipping and our policies aiming at carbon neutrality in international shipping. As shown in the pie chart, CO2 emissions from international shipping account for about 2.1% of the world's total emission, which is approximately equivalent to emission from Germany. The total seaborne trade is expected to continue to increase in the medium to long term as the world economy grows. Some estimates that CO2 emissions from international shipping will be account for 7% of the world's emissions by 2050 without any mitigating measures. As international shipping involves a wide variety of stakeholder countries, GHG emission reduction target and measures are being discussed and developed under IMO, International Maritime Organization, which is one of the United Nations specialized agencies. Under the IMO regulation framework, energy efficiency of ships has been greatly improving for decades. But to achieve further large volume reduction of GHG emissions, the change of ship fuel is inevitable. The whole picture of this shift is still not clear, but it is expected to shift from heavy fuel oil to LNG. This is already occurred. And then to zero-emission fuels such as ammonia and hydrogen. To make this great shift successfully and smoothly, the government and the private sectors need to jointly address many issues in the field of technologies, regulations, human resources, production facilities, and fuel supply chains. On October 26 last year, the Ministry of Land, Infrastructure, Transport and Tourism, (MRIT), and the Japan Shipowners Association, JSA, announced that MRIT and JSA are aiming for carbon neutrality or net zero GHG emissions in international shipping by 2050. Major member companies of JSA have also announced to aim at net zero emission by 2050. Japan has proposed with US, UK, and others to IMO that this should be set as a common global goal. Discussions on revision of IMO GHG strategy, which includes the emission reduction target and reduction measures, will continue at MEPC 79 held on December this year, with the aim of reaching an international agreement at MEPC 80 held on July next year. Japan is committed to lead the discussions and contribute to form the constructive agreement in IMO. Last year, Japan launched the development project for ammonia and hydrogen fuel ship with a total budget of 35 billion yen. This project, called the Development of Next Generation Ships, is one of the projects supported by Green Innovation Fund. In this project, core technologies of ammonia and hydrogen fuel ships, such as engines, fuel tanks, and fuel supply systems, are to be developed to install trial ships. There are challenges identified for development of ammonia and hydrogen fuel ships. For example, in engine development, hydrogen burns at a high rate and is prone to abnormal combustion. Ammonia has another type of problem that is possible producing N2O, which has a greenhouse effect 300 times greater than CO2. To solve those issues, it is necessary to develop advanced combustion control and fuel injection technologies. Solving those challenges through the project, ocean-going trial operations are planned to be conducted in 2026 for ammonia fuel ships and in 2027 for hydrogen fuel ships. We continue to contribute to realize carbon neutral in international shipping by 2050, together with private sectors and foreign countries. Thank you for listening.
Mr. Tamura, thank you for your impressive presentation. Now we will move to the next presentation. Next speaker is Ms. Rebecca Thompson. Ms. Thompson is a manager, Hydrogen Strategy Team, Department of Climate Change, Energy, the Environment and Water, the Australian Government. Now the next presentation, please.
Good afternoon, and thank you for inviting me to present at the Innovation for Cool Earth Forum. My name is Rebecca Thompson, and I'm the manager of the Hydrogen Strategy Team at the Australian Department of Climate Change, Energy, the Environment and Water. In this session, I will give an overview of Australia's National Hydrogen Strategy and actions to build the industry. Firstly, I'd like to introduce Australia's vision of becoming a global renewable energy superpower. Australia has committed to an ambitious target of reducing greenhouse gas emissions by 43% below 2005 levels by 2030. We lodged this new 2030 target and reaffirmed our 2050 target as an updated nationally determined contribution under the Paris Agreement on the 16th of June 2022. The legislation for this target passed Parliament on the 8th of September. Our policies, especially those under the Powering Australian Plan, directly support new clean energy industries and the decarbonisation of existing industries. This includes investing $20 billion in modernising Australia's electricity grid to unlock greater penetration of renewable energy, installing 400 community batteries across the country, and investing in 10,000 new energy apprentices and a new energy skills program. The government has committed up to $3 billion from the National Reconstruction Fund to invest in green metals, clean energy component manufacturing, hydrogen electrolyzers, fuel switching, agricultural methane reduction, and waste reduction. Our plan will see the portion of renewable energy in our national energy market increase to 82% by 2030. Australia moved early to build a hydrogen industry with the development of the National Hydrogen Strategy in 2019. At that time, we were one of only 3 countries, the others being Japan and South Korea, to have a strategy. The strategy provides a framework for Australian governments and industry to work together to position Australia as a major exporter of hydrogen as the world moves towards net zero emissions. We have made significant progress on the 57 nationally coordinated government actions that were set out in the strategy. Since the release of the strategy, Australian governments have been undertaking a range of activities to support early industry growth. These include reviewing how to remove unnecessary regulatory barriers and harmonise regulation through a national legal frameworks review, reviewing the changes needed to improve workforce skills and training, assessing the infrastructure needs to support a large-scale hydrogen industry, supporting projects, trials and demonstrations, developing an internationally aligned guarantee of origin scheme to measure and display key attributes of how and where hydrogen is produced, including its emission intensity, and finally, working with industry to earn the community's trust and build confidence about hydrogen. Australia is on track to achieve our vision to be a major hydrogen exporter by 2030. We have a world-leading pipeline of around 100 clean hydrogen projects. In 2021, hydrogen, ammonia and carbon capture and storage projects accounted for around $185 billion worth of potential investment. There is also significant growth in proposed gigawatt-scale electrolyser projects. Based on publicly available information, there are at least 6 proposed gigawatt-scale projects, including the Asian Renewable Energy Hub in the Pilbara region of Western Australia. The Asia Renewable Energy Hub is proposed to comprise of 26,000 megawatt hours of upstream wind and solar to make green hydrogen and ammonia. It was granted major project status by the Australian Government in September 2020, formally recognising its strategic significance to the Australian economy. The project will build on Australia's strengths as a major energy exporter while helping to reduce global emissions. Building international partnerships is also an important component of our hydrogen strategy. Over the past 18 months, Australia has been developing a series of bilateral international partnerships seeking to advance cooperation on clean energy technology. We have partnerships with 7 countries that feature cooperation on clean hydrogen. These partnerships are already delivering outcomes. For example, Australia sent its first shipment of liquefied hydrogen from the Port of Hastings in Victoria to Kobe in Japan as part of the Hydrogen Energy Supply Chain Project in early 2022. This is a joint project between the Australian and Japanese governments and Australian and Japanese industry. It is an important milestone as it is the first project to make and transport liquefied hydrogen between 2 countries by sea. Australia is also engaging in multilateral forums. For example, we're co-leading a new Mission Innovation Clean Hydrogen Initiative, and we're working through the Quad Hydrogen Partnership to deepen collaboration with trading partners on diversifying and securing energy supply chains, particularly in the Indo-Pacific region. Thank you again for the opportunity to present today, and I look forward to participating in the panel discussion later this afternoon.
Thank you, Ms. Rebecca Thompson. Yes, thank you for your impressive presentation. Now we will move to the next presentation. Next speaker is Mr. Rao Wei Jie. Mr. Rao Wei Jie is a Director, Partnerships, Global Center for Maritime Decarbonization. Now the next presentation, please.
Good morning, good afternoon, and good evening everyone around the world. My name is Wei Jie, the Director for Partnerships at the Global Center for Maritime Decarbonization, or GCMD. GCMD is a relatively young organization founded in 2021, and our mission is to help eliminate GHG emissions for the shipping industry by shaping standards, deploying solutions, financing projects, and fostering collaboration across sector. Allow me to run through with you 4 of our current project tracks and share with you some of our insights when we discuss and commission these projects. The first project we commissioned is to establish the safety and operational parameters for us to bunker ammonia safely. This project was awarded to a consortium comprising of DNV, Savannah Jurong, and the Singapore Maritime Academy to help us establish the technical references required for ammonia bunkering to take place, and also to identify 2 potential sites in Singapore for the trials. The reason we chose Singapore as a site for the trial is because Singapore is the top bunkering hub, and there are a lot of other activities happening concurrently while bunkering is taking place. We think that if we can safely bunker ammonia here in Singapore, we can actually proliferate this study to elsewhere and also to customize it for overseas ports in order for them to also proliferate the use of ammonia in their home ports. When we talk about the future green fuels, you will know that they are actually similar to their grey counterparts. And these questions in terms of how we can provide assurance from a quality, quantity, and abatement potential perspective. Given so, we have launched a project on the assurance of drop-in green fuels just in July. And also, we are piloting it with biofuels because biofuels are currently commercially available. This allows us to build on and also to refine the framework before we move towards the other alternative green fuels, such as your bio-LNG, your synthetic methanol, and also your e-ammonia when this comes into play. We see carbon capture as a potential pathways to help shipping decarbonize, mainly because a lot of these green fuels will still contain carbon dioxide in the exhaust. However, there are challenges associated with the use of CO2 capture. This includes the energy requirement of your shipboard carbon capture systems, and what do you do with the captured carbon dioxide? So our pilot will focus on what is the optimal capture rate that we can get without significantly increasing the amount of energy demand and hence fuel consumption of the vessel. And we are also going to start embarking on a study to look at how we can offload CO2 that has been captured. We want to move towards offloading pilot and also to storage and utilization pilots when these are ready in future. We see near-term retrofit as one of the earlier solutions that can be adopted. And currently we are evaluating a wind-assisted ship propulsion solution that can potentially reduce the capex required for the adoption of such a wind-assisted ship's propulsion solution. This project is under evaluation, and we expect to share more when it has been ready for us to support. GCMD started with 7 founding partners, including BHP, BW Group, Foundation, DNV, Eastern Pacific Shipping, ONE, and of course, Sembcorp Marine. This is together with MPA. Moving from there, we have actually onboarded other partners, including BP, Hapag-Lloyd, BCG, Chevron, and coalition partners such as ICS, IBIA, Singapore Shipping Association, International Windship Association, and our legal consultant, Ashes. We are also in close contact with all knowledge partners, such as the Merce McKinney Moeller Center, and also the Global Maritime Forum. We are also happy to have on board Kepler, who has provided us with data for us to undertake some of our analysis and modeling as a cost of our work. I look forward to our discussions later, and thank you for listening to my presentation. Thank you.
Mr. Lau Weijie, thank you for your impressive presentation. Now we will move to the next presentation. Next speaker is Dr. Nishimura Motohiko. Dr. Nishimura Motohiko is an executive officer, Hydrogen Strategy Division, Kawasaki Heavy Industry Limited. Now the next presentation, please.
Hello, everybody. My name is Motohiko Nishimura from Kawasaki Heavy Industries. Today, I briefly present you about Kawasaki's activities to realize international hydrogen supply chain. Kawasaki is an integrated heavy industries with century of experience in a wide variety of technologies such as land, sea, and air transportation vehicles, energy plants, robots, and so on. By applying such technologies, we have been developing products that are necessary for realization of hydrogen energy supply chain, ranging from hydrogen production to transportation, storage, and utilization. Kawasaki started the hydrogen energy supply chain project since 2010 to transform the energy market and accelerate carbon neutrality. Hydrogen is expected to play an essential role in carbon neutrality, energy security, and economic growth of our society. The Japanese government has identified hydrogen's potential and set forth ambitious targets to be achieved in order to promote the use of hydrogen. To meet the growing demand for hydrogen, there is a need for the international hydrogen supply chain comprising of hydrogen production in countries where energy is vast and thus cheap, liquefaction, transportation, storage, and utilization. This is the concept of international hydrogen supply chain that Kawasaki is promoting. We are aiming to develop hydrogen supply chain producing hydrogen overseas from affordable resources and transporting to Japan in the form of liquefied hydrogen. We have selected liquefied hydrogen as a hydrogen carrier. This is because liquefied hydrogen is non-toxic and clean. It is also highly pure and can be supplied directly to fuel cells after evaporation. Therefore, it doesn't consume energy when it is utilized in Japan. Kawasaki is working together with partners in a pilot demonstration project to establish an international hydrogen supply chain between Australia and Japan, targeting its commercialization. With the support of Japanese, Australian, federal, and Victorian state governments, Kawasaki and its partners successfully operated the world's first liquefied hydrogen carrier ship, the ICEF2022, which has been built by Kawasaki, and completed a pilot demonstration project for an integrated liquefied hydrogen supply chain between Australia and Japan. In the HESC project, hydrogen was produced in Lateral Valley with gasification process using a mix of Victorian coal and biomass. Then liquefied and loaded onto ICEF2022 at Hastings Port for transportation to Kobe, Japan. The pilot completion ceremony was held at the hydrogen receiving terminal in Kobe, with attendance of the Japanese Prime Minister Fumio Kishida. Looking back to the development of LNG equipment, it took a long time for scaling up. But with our great deal of know-how for LNG and liquefied hydrogen equipment, and also with evolution of computer simulation technologies, we could accelerate the development for scaling up of liquefied hydrogen equipment. For the next step from the HESC pilot project, a commercialization demonstration project has been selected by the Japanese Governmental Green Innovation Fund. A large-scale liquefied hydrogen supply chain will be in the demonstration middle of 2020s, which will progress to commercialization in early 2030s. We are currently undertaking feasibility studies to identify the most appropriate project structure. This project is conducted by Japan Suiso Energy with ENEOS Corporation and Iwatani Corporation. Japan Suiso Energy is Kawasaki's affiliate company. With regard to the hydrogen utilizing facilities, we have been operating a hydrogen-filled gas turbine cogeneration demonstration plant on the Kobe Port Island since 2018, jointly with our partners shown on the slide with red characters. Kawasaki has been developing various products like these shown on the slide that are necessary for hydrogen deployment to the society. Among these developments, hydrogen aircraft, hydrogen reciprocal engine, and hydrogen liquefier are supported by the Green Innovation Fund. Kawasaki is fully focused and committed to develop the necessary hydrogen technology of the supply chain and demonstrates the feasibility of hydrogen commercialization. I am truly convinced that this will deliver a new clean hydrogen economy to the world for the benefit of our environment and for the sustainable future of generations to come. Thank you for your attention.
Dr. Nishimura, thank you for your impressive presentation. Now we'll move to the next presentation. Next speaker is Mr. Komatsu Yu. Mr. Komatsu Yu is a director Asia Yara Clean Ammonia. Now the next presentation, please.
Thank you for giving me the opportunity to present Yara Clean Ammonia activities at the ICEF2022. We believe ammonia is key to decarbonize the world. There is no other chemical and other products that can help decarbonize hard-to-abate industries such as transportation industries and shipping, such as power industries, for instance, coal power plants, but also in decarbonizing agriculture, which is significant customers of ammonia today. We believe ammonia is a key solution, and Yara Clean Ammonia is a key player in ammonia space. Yara Clean Ammonia is world's largest distributor of ammonia, and our platform of terminals, vessels, as well as upstream production plants and multiple outlets give us roughly 20% market share worldwide and a leading position in the shipping ammonia. This platform is an excellent starting point for the future and for the growth that we expect, particularly serve market around the world of clean ammonia, including Japan. Our global system has built significant network both of production plants as well as receiving plants and terminals. We have production assets in all major regions in the world, particularly our asset in Australia enable us to support Japan as we supply Japan already today and make us well positioned for future growth of clean ammonia as well. Collaboration is critical for the change ahead of us. YCA is working closely with several Japanese partners both in power generation, refineries, shipping, and petrochemical sector. These collaborations are critical to us in order to establish the competitive supply chain to Japan. They are critical in order to link the future downstream demand with upstream project portfolio that we are developing. We are very grateful for the trust and the confidence that these significant Japanese companies have put into Yara Clean Ammonia. Being reliable and asset-backed supplier, having global scale and flexibility to deliver anywhere in the world. 100 years experience with dealing ammonia, both market perspective and safety perspective. Track record of safe operation and safe shipping, as well as existing and long-term customer relationships are critical for our success and critical going forward. YCA handle entire value chain from upstream to downstream, particularly our integrated midstream position, which integrate producing plants with customers. We ensure that our customers receive ammonia they need when they need it, and we also ensure that our suppliers get offtake that they need when they need it. We believe this is a critical part of our competitive edge. We are looking to grow in order to deliver the future needs of clean ammonia. We need a new production as well. Yara Clean Ammonia has a portfolio of projects both in terms of transforming Yara's existing plants to clean ammonia, as well as new production. We are looking at blue ammonia production in US Gulf that we have both projects to change our existing plants to be blue, as well as building new blue ammonia capacity in US Gulf. In addition, Yara engaged in several green ammonia projects. We have a pilot project in Norway, 24 megawatt ammonia project based on electrolyzer already in construction that will be finished by next year. In addition, we are collaborating with several other green ammonia projects where Yara will be off-taking as well. All in all, this provides a significant supply base in order to supply future customers. Thank you for your attention.
Mr. Komatsu, thank you for your impressive presentation. Now we move to the next presentation. Next speaker is Mr. Yokoyama Tsutomu. Mr. Yokoyama Tsutomu is a General Manager, Green Business Group, NYK Line. Now the next presentation, please.
Hello everyone, my name is Yokoyama at NYK Line. It is a great honor for me to make a presentation in this significant event. Let me introduce ourselves, NYK. We are a shipping company. Our fleet size is more than 800 vessels, covers most of the type of the cargo vessel. Furthermore, we operate the aircraft terminal, and we also offer onshore basis logistics service, more than 600 locations globally. Let me touch upon decarbonization trend in shipping. As a matter of fact, international shipping emits for 2.0% of world CO2. Under those situations, International Maritime Organization set various regulations. For GHG reduction, current target is 50% by 2050. But obviously, this is not good enough. IMO plans to adopt a resolution in 2023 to set net zero at 2050. As for Japanese government, they already declared carbon neutrality in international shipping 2050. As for NYK, we also declared long-term target of net zero emissions of GHG by 2050 last year. We recognize ammonia as one of the most realistic alternative zero-emission fuels. However, we don't rule out other solutions like e-methanol, hydrogen, biofuel, and so on. For the time being, focus on LNG as immediate low-emission measure as bridging solution. Currently, most of our vessels are powered by conventional type of oil, but we will build LNG-powered vessels and gradually increase number of those type of vessels. And around 2028, we will build and implement commercialized ammonia-fueled ships and gradually increase the number of such type of vessels to achieve net zero 2050. We have subsidy by Japanese government, which is called Green Innovation Fund. We have two projects. One is ammonia-fueled tugboat to be delivered in 2024. The second project is ammonia-fueled ammonia gas carrier to be delivered in 2026. We formed a consortium together with shipbuilder Nippon Shipyard, Classification Society, Class NK, and engine manufacturer Japan Engine, IH Powers, also supported by the Japanese government. We are pleased to say Japan's maritime industry leads global maritime decarbonization in R&D and the realization of ammonia-fueled ships. Currently, there is no international regulation to exist for the use of ammonia as marine fuel. We are also required to secure safety level equivalent to existing liquefied gas fuel ships. Under those situations, the world's first Hajit study for AFAGC completed in July 2022. Also, approval in principle for AFAGC design awarded in September 2022. So I can say project has passed the critical milestone and continues to make further progress towards realizing AFAGC by 2026. Lastly, let me introduce contributions in industry associations. One is Mask Makini Moral Center for Zero Carbon Shipping. This center is committed to seeing commercially viable deep-sea zero-carbon vessels powered by zero-carbon fuels. We, NYK, participate as founding members. The other one is Global Center for Maritime Decarbonization, which is located in Singapore. NYK contributes to the GCMD as an expert on bunkering fuel development. Lastly, NYK commits to make best effort to realize ammonia supply chain as shipping company. Thank you very much.
Mr. Yokoyama, thank you for your impressive presentation. Now we will move to the next presentation. Next speaker is Mr. Peter Kirkeby. Mr. Peter Kirkeby is a principal specialist, technical promotion, two-stroke promotion and customer support, MAN Energy Solutions SE. Now the next presentation, please.
All right, everyone, thank you for tuning in. Now a little bit about our development project of a two-stroke ammonia-fueled engine for merchant ships. Now, a two-stroke propulsion engine for basically the majority of the merchant ships out there is available with 4 different fuels today in a dual fuel configuration. This means the engine can run both on conventional oil but also a second fuel. Currently we have LNG, ethane, methanol and LPG available. In the future we are looking to develop an ammonia dual fuel engine that can run conventional fuel and ammonia. Currently what we see is LPG and ethane are only used on ships that can use their cargo to propel the ship. So basically an ethane carrier or a gas carrier. For LNG and methanol, we see a very big interest from ships that are dual fueled, meaning they do not carry these substances as a cargo, but actually bunker them to use it as fuel. There is quite a lot of interest in using ammonia as a fuel, both on ammonia carriers, but also on dual fuel ships. This is because green ammonia, of course, has the promise of being a pathway to decarbonization of shipping. So, now a little bit about our engine development project and how we see this introduced into the market. So, we have worked on this, as you can see from the plan here, for quite a while. The exciting part will come later this year, where we aim to test on 1 cylinder on our test engine here in Copenhagen. That will then transpire into a full-scale engine test, meaning 4 cylinders on our 50-bore test engine here in Copenhagen. And then by 2024, we will have testing at Mitsui in Tamano, where we have a cooperation on what will be the first engine to go into a ship fueled by ammonia. So that will be testing in 2024 simultaneously with our engines in Copenhagen and go through probably quite a few iterations as we learn about this, and then eventually transform into a commercial engine product that goes in this very first ship. So what we have done so far is, of course, investigate what can we do with ammonia, but also we have established the test facilities and developed all the auxiliary and supply systems needed to run an engine on ammonia here at our test center. And this is a very important step, because without these systems, of course the engine cannot run here at our facility, but it can also not run in a ship. So the development of these is crucial. Now, to show you just a few bits from this development, what you see in the top left is the cylinder we will be using on our 50-bore test engine. The bottom left is the cylinder cover, or cylinder head with the ammonia injection equipment mounted, all the controls needed for that, and the inlet and outlet double wall pipe which we use to supply ammonia on the engine. What you see on the bottom right is our ammonia tank and bunkering facilities. Then we move up to the middle picture here where we see the supply systems kit where the ammonia is put into the engine with 83 bar in liquid state. And what you see on the top right picture is the gas valve train, which is the safety feature that separates the fuel gas train from the engine. Now, what you will note from fuel gas supply system as well as the gas valve train is these are mounted on skids. They are very similar to the installation you put into a ship, and these are actually a very manageable size. As far as the market launch, as mentioned, we are very lucky to be able to test an S60 design with Mitsui that will then go into a ship that will be the pilot project for an ammonia-fueled engine. Once this engine goes sailing, which we assume is sometime in 2025, there will be a period where we need to establish good service experience and learn as much as we can about these engines so that we can ensure a commercial launch of an two-stroke ammonia technology is ready. And that is very briefly about the plan for launching the engine. We are very focused on safety, and we are focused on that we need to develop an ammonia-fueled engine that can satisfy all the expectations that you have to a normal two-stroke marine engine. So, an S60 bore, this is interesting because it fits many different segments, and once developed, it opens up for ammonia-fueled pilot projects in many different segments of shipping. So, that was my brief introduction. Thank you very much for your time.
Thank you, Mr. Kirkeby. Thank you for your impressive presentation. Now we will move to the next presentation. Next speaker is Mr. Akamatsu Takeo. Mr. Akamatsu Takeo is a General Manager, Green Innovation Business Unit, Plant Project, Marine and Aerospace Division, Machinery Company, Itochu Corporation. Now the next presentation, please.
Hello, good afternoon. First of all, thank you very much for this opportunity to explain our challenge. So before our presentation, we try to introduce ourselves. Itochu Corporation is trading house, not a shipyard, and not a shipping company. So our approach is to make an integrated project, so which means we try to develop not only shipbuilding side but also shipping and fuel to make integrations. Early 2020s, we started with partners here in Israel, MA Energy Solution, Mitsui & Machinery, Plus NK, and Itochu Group to develop ammonia fuel vessel together. And thereafter, we invited the shipping company partners, K-Line and NS United Cayons. And at the same time, in 2021, we obtained support from Green Innovation Fund. And thereafter, we are under development of a pilot project with potential end users. But at the same time, the bunkering side, we executed MOU with the partners here in 2021, Pavilion Energies, Total Energies, MOL, who are doing a bunkering service with LNG fuel, and BOPAC, who have a facility of ammonia in Singapore. Then thereafter, we obtained the AIP of ammonia bunkering vessel with MOL and SEMCO planning. Then thereafter, early this year, we executed the MOU with MPA to accelerate ammonia bunkering business in Singapore. In order for us to develop, expand ammonia project, so we need shippers to join us. So we decided to establish joint study frameworks with shippers to study together about ammonia fuel. So we set up a common issues: safety for ammonia vessel, safety for bunkering, ammonia fuel specification, and net CO2 emissions. But as to safety for bunkerings, we found we need to discuss with port authorities. So early this year, we also established separate framework for ammonia bunkering safety with various port authorities, including Singapore MPA and Japanese Emirate. For the time being, we are focusing on key factors to develop the design of both ammonia fuel vessel and bunkering vessel. Lastly, we'd like to explain our challenge from now. Before that, we should wait for the result of engine test, which is now carried out by MA Energy Solutions, and also preparation of the bunkering safety guideline by port authority such as MPA. Then thereafter, we'd like to develop the pilot project, which is large-size bulk carriers, with the partners to obtain FID by early next year to deliver the first vessel early 2026. However, in order for us to achieve such target, we need commitment of net zero by each stakeholders in various categories and very strong demand from end users with fair value of zero emission shipping. I think that is key factors for decarbonization in shipping industries. Thank you very much.
Mr. Akamas, thank you for your impressive presentation. This is the end of the presentation session. Following the presentation, we will have panel discussion regarding a challenge toward global supply chain carbon neutrality, and Professor Hiekata will act as moderator of this panel discussion. Now, I would like to hand the microphone to Professor Hiekata. Professor Hiekata, if you please.
Yeah, thank you very much. Then we'd like to move on to the discussion, panel discussion. And today, we learn latest technologies and ideas from your presentations. Then now an ammonia and hydrogen technologies are actively being developed, and stakeholders are also explore how to use them. Then we should discuss here and how to synthesize these ideas and technologies to accelerate the carbon neutral transitions and for supply chain and maritime industry. Okay, then in that context, let me propose 2 points. First one is promotion of corporate activities. Second one is how to cooperate internationally. Then we'd like to have these, we have these 2 points for discussion and discussion and in this panel. Then as for the procedure, first, I'd like you to give comments. I'd like you to comment on both points. Then order. Let me ask the order. I'd like you to comment in order of this switching. Then Dr. Imran, could you start your comment first?
Thank you very much, Professor Hiekata. These 2 points are very good point. What I would say is very much a considerable consideration we need. And first of all, the carbon neutralization of supply chains cannot be achieved by the efforts of any single country. The huge global investment is needed in carbon-free fuels and zero-emission mobility from production facilities, infrastructure, transportation, utilization, and so on. So in order to boost corporate innovation and investment activities through behavior changes in government, financial markets, and consumers, it is important to engage these stakeholders from an early stage. And this requires active provision of information. As a national funding agency, NEDO intends to actively provide information on the initiatives of the Green Innovation Fund, both domestically and internationally. We believe that future vision and ongoing process should be disclosed from the technology development stage, early stage, to create a situation or environment that facilitates policy planning and investment both in public and private sectors. So this event is a great opportunity for such activity, active provision of information. I would also like to make one more comment briefly. In disclosing information, it is necessary to accurately assess the quality of product, finance, and investment. It is also necessary to have a common international understanding of how to disclose that a product is a green product. The definition of the green product and the methods of assessment and measurement. In this regard, formulating rules not limited to business, such as regulations set by government, is also needed. Thank you very much. This is my first comment.
Yeah, thank you very much. Let me write down some key comments. Then, because of the time limitation, and first, let me go around the table. Thank you. Then the next, Mr. Tamra, could you give some comments?
Okay. Thank you very much. To encourage stakeholders to boost the introduction of zero-emission ships to achieve carbon neutrality by 2050. On top of the acceleration of technology development using the Green Innovation Fund, it is also important to provide another type of incentives for introduction of zero-emission ships. For ammonia and hydrogen ships, it is likely to cost more in both CAPEX and OPEX compared with conventional heavy fuel oil ships. It could retard widespreading of such ships even if the technology development is successful. To address this issue, Japan is proposing the fee-based mechanism to the IMO as their global market-based mechanism. This fee-based mechanism gives rebate to zero-emission ships by using the fee collecting from ships using fossil fuel. This mechanism focusing on giving support for fast movers who take risks in order to combat against global climate change. It will be also important for policymakers to consider providing support to the initial cost of introducing zero-emission ships. And we would like to seek providing some kind of support for such fast movers in shipping and related industries. Thank you very much.
Yeah, thank you for valuable comments. And let me go to the Miss Thompson.
Oh.
Thank you, and we can hear you.
Thank you. So some points on the first question for me. So I think measures that are important for encouraging innovation and investment in supply chains. That really, I think, are getting the enabling environment right and the regulatory environment, and this includes establishing certification or guarantee of origin schemes to certify the low emissions credentials of clean or green products. This is really important to give consumers assurance over the products they're buying and establishing markets and international trade. I think also, as other speakers have mentioned, there is a very big investment in infrastructure that is going to be needed for these new industries. I think to ensure this infrastructure develops in a way, the planning of that infrastructure and encouraging shared infrastructure, or the use of shared infrastructure is very important. One mechanism that we can look to use to do this is the creation of clean energy or hydrogen hubs, you might want to call them, or hydrogen valleys, they're sometimes called. These are where you may co-locate a number of businesses in the clean energy supply chain, including producers and consumers of low emissions products, and co-locate these together. This can be a way of driving down costs and concentrating investment in particular areas, and making the most of the use of shared infrastructure. And I think the development of these hubs in the early stages of an industry can really help achieve efficiencies and drive down costs. A couple of things that I think are really important are going to sort of workforce and skills that we need, and just making sure or trying to identify the skills that are needed for these industries and supply chains, and identifying and developing training programs. Also ensuring community support for some of these projects will be critical going forward as well. So they're my initial comments. Thank you.
Thank you very much for your comments. And okay, now first step, let me go around the table. Mr. Wei J. Lau, could you give comments on these 2 points?
Hello, everyone. So in terms of promoting corporate activities, what I think we need is also, looking at how we can define sandboxes for us to undertake pilots and trials. I think this is one thing that will help move things before actual regulations are out. Is there a possibility to look at, what are some of the risks, from a risk-based approach, how can we enable trials happening within the port areas or within the voyage areas? And that will actually provide a lot of learnings in terms of what needs to be in place and what we can actually remove from the safety guidelines. So the other thing we talked about is really to work with the stakeholders to understand what are the exact gaps to be addressed before these rules can be deployed. So for example, just now I mentioned about GCMD working on ammonia bunkering. There are also more finer details in terms of where it can be done, how to get the permits to do it, and this actually can help to unlock some of the barriers that needs to be addressed before we can actually do ammonia bunkering commercially. Also, just before me, Rebecca mentioned about the competency framework, and I think that's important, especially when we talk about how to recognize not just within a country, how to recognize internationally the different competency requirements before the crew are able to address or handle ammonia as a fuel. So this needs to be recognized internationally. Yeah, in terms of how we cooperate internationally, standard development will be important. So competency again is something that we can look at. Other things include, your safety requirements, bunkering standards, even down to the level of what sort of pipeline configuration should be there, so that people at different ends of the same voyage can actually address or transfer ammonia safely, transfer alternative fuel safely, would be very critical. And also, again, in terms of green certification, I think that's important. Especially in GCMD, we're actually working on a project to provide an end-to-end green certification or green verification framework to provide quality, quantity, and abatement assurance. And we think, again, this cannot be just done by a single country. It has to be done internationally and recognized across the border. Thank you.
Okay, thank you very much. Okay, then let me move on to Dr. Nishimura. Could you give some comment, please?
Yes, so to promote corporate activities, I think realization of large volume demand is of importance. In such aspect, as Mr. Tamura said, incentive to fast movers is very, very appreciable. Because if once the long-term economical feasibility and validity is ensured, investment to the also upstream hydrogen production country and supply chain can be induced. And also to achieve the large demand, we have to achieve the large volume production and transportation. That's why we are now conducting commercial demonstration project under the Green Innovation Fund support. Thank you.
Yeah, thank you very much. Thank you very much for your feedback. And the next one is Mr. Komatsu. Before your comment, could you speak a little bit slowly because some sound is not an echo, but the sound is something different and from the panelists in here and the online panelists. So could you speak a little bit slowly? Mr. Komatsu, could you give some comment, please?
Thank you very much. I think, sorry, my reply will be a bit vague, but I think the clarifications of potential issues in new value chain has to be done at the first place. Since industrial boundaries started to be shifted quite rapidly, understanding really new value chain is getting more difficult. So that's why I believe a good understanding of new value chain is significantly important to clarify the potential issues behind this new value chain. In order to do so, we consider partnership will play an important role, and we believe such a partnership has to be quite mutual and complementary. And bringing the core strengths by each other in a quite transparent way, we can deepen our understanding of the new value chain, and we would be able to see several potential challenges which have to be solved together. And through such a process, we will be able to clarify the issues which are behind the new value chain, and from there, we can solve the problem together. So I think that our first reply to me, reply to you. And the second one is somehow related to my first reply to the first questions. It is again somehow related to previous questions, but I believe the understanding of core strengths of each potential partners, stakeholders, is quite key to identify the issues. And through such a process and a partnership, we could deepen our understanding of a new value chain, and we may be able to suggest new rules if such is really required. Yeah, thank you very much.
Okay, thank you very much. Then let me move on to Mr. Yokoyama. Could you please?
Yes, thank you very much. As for the first one, promotion of corporate activity, firstly, especially at the beginning stage, we would like to see the sufficient government initiative, which actually I've already seen through the Green Innovation Fund. And then two chunk of area we need support for initiative. One is technical development, which is now in progress and supported by the Green Innovation Fund again. And second one is implementation. We are now developing the ammonia-powered tugboat and also ammonia-powered ammonia carrier to be delivered 24 and 26. We believe we can satisfy, we can meet our schedule and deliver and operate those two vessels in timely manner. However, this is just the beginning. We have to build and operate second vessel, third vessel, and enlarge our fleet as shipping company. But after second vessel, currently there is no subsidy. We should, of course, we should not rely on subsidy too much. But for the implementation phase, we need some support. Otherwise, it is really, really difficult. Our customer, our valued customer, cargo owner, has a keen interest or a keen concern for the global greenhouse gas emission reduction or environmental issue. However, they are working very hard, competing very hard in their each industry. So therefore, we are under impression to convince, persuade them to fully cover the additional capex due to the zero emission vessel cost. So I have a similar experience in the LNG fuel. This is not zero emission, but lower emission. It is said that 30% reduction of CO2. I believe that's true. In 2016, we world first built new large-scale cargo vessel and assigned our European trade, because Europe is the most advanced, the most restricted area for the environmental requirement. And then our valued customer in Europe, they advertise and they declare the environment is very, very important. We have to contribute, blah, 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 blah. However, at the time of the contract and regulation, it was, in reality, it was not easy to convince, to accept them to additional cost, capex and opex. That is reality. So then the environment in society globally totally changed after some years since then. But still, as shipping company, we are not optimistic. Additional cost to ask our customer or cargo owner to bear all the cost. So therefore, again, the beginning stage, we need some support. That's the point I'd like to say. And also, in addition to the financial support, the second point is some regulation issue or permission or approval or such kind of issue. In case of this kind of new technology or new energy, especially the ammonia is very toxic object. That's, we have a key interest about the safety. And then authorization, government body, like who is supposed to authorize, to approve, to use ammonia, they are very, very carefully evaluate the safety. That is quite important. And actually, we have already started such a discussion with Japanese governmental body to get approval. That we have completed some risk assessment, but sometimes we feel that we lose some flexibility, and we spend too much time to get such a new type of fuel. Again, safety first. That is our very fundamental philosophy, policy, no room to compromise. But I think we have some flexibility, especially in case of challenging this kind of new zero emission energy implementation. And for the second point, a very simple comment I'd like to say for the corporate internationally. I'd like to see the very fair and transparent discussion. And then we'd like to see the global basis consent or agreement. Each area would like to say the idea which cater their own interest. So we'd like to eliminate such each party or each area's interest. We'd like to see the common agreed global basis rule. One example, we say green ammonia or blue ammonia, and then that green ammonia is very, very clear, developed or created by the renewable energy, quite simple. On the other hand, blue ammonia, the definition has not been finalized yet. In Japan, we have a very, very good discussion supported by government initiative and the Clean Fuel Ammonia Consortium. But still, we don't see the clear agreed definition globally. Recently, LNG, we have built so many LNG-powered vessels, and then because which is proven technology, and we can reduce immediately. However, some people say LNG is not good for environment. For their assessment, LNG does not contribute. Such comment we see sometimes. So therefore, we don't want to avoid such a less organized comment. We would like to see the agreed regulation and definition. Thank you very much.
Well, thank you very much. I think really insightful comments. Okay, then let me move on to. Let me move on to Mr. Kirkway.
Thank you very much.
Could you speak slowly again? You are online. Thank you.
Very good.
Go ahead.
Thanks. So, I think for us, we are a small technology provider, and we think the establishing and developing this engine is difficult and complex. But I think, as very well illustrated by Akamatsu-san from Itochu, this is only a very small part to bring only the first ships out sailing to learn. This is immensely complex. What we have been lucky, and I think that is illustrated, is through the upturn and enormous optimism for shipping in the past 2 years. We have seen a lot of momentum. We have seen the Global Center for Maritime Decarbonization cooperating globally. We have seen the Maersk Mc-Kinney Møller Center here in Copenhagen also establishing this wide cooperation. But also can see and share, let's say, the concern from Yama-san from NYK that we might lose momentum, especially if we're looking into a future that is less positive. Then this momentum needs to be kept. And yes, the first movers are currently seeing a lot of we're seeing a lot of support for the first movers, but this will take time. We need to keep momentum, and this is where there's a responsibility for us in the business to make sure that we illustrate that we need some support in a complex matter, and we are also very open about what is possible now, what can be possible in the future. As far as what we can do internationally, this is a difficult one. I certainly agree that a transparency is needed in whatever system we come up with to promote the green transportation. If it is directly something that illustrates to the consumers why there might be a small increase in transportation costs, or however that's implemented. I think we do have some luck that in the past 2 years it has been illustrated worldwide how vulnerable the supply chains are, and maybe this can help. At least now it is in the mindset of people that it is needed. Another very important comment from Ms. Thompson and Mr. Lau was making sure that we get the right people and we keep not only on the development side, but basically the operation of the ships. We need to have the right people, we need to be able to offer the right education, and we need to be able to offer this as a very attractive future, basically, for the young hearts and minds who are choosing what they will do after their university, and those who choose what they will do even at an even younger stage. So, thank you very much. Those were my few words.
Yeah, thank you very much. And then move on to the last person, Mr. Akamatsu, could you give comments on these two points?
Okay, thank you very much. So, as a last person, maybe almost everything is covered by the people here. But I think we can add, as Yokomura-san pointed out, if the clients talked about cost, then it's very difficult to introduce zero emission, because we have to say zero emission is the value. So this is not cost up, this is value up. Then how we can say zero emission is a value up? Because this is a demand by clients. So if it is a shipping, so charter is clients, direct clients, but the charterers, they have also their clients. This is a supply chain. So how we can create the system, people, all stakeholders, all people in the supply chain intend to shift zero emission? That is the questions. And of course, first movers support incentive is very important. But in order for us to discuss about substantial transitions, I think we should change in the way of thinking. And so we are very much waiting for a guideline by accounting policies to talk about the Scope 3 guideline. Then at least a stock listed company, they can demonstrate what is their emission, Scope 3. Then they can declare what is their target. Then stock market, they can evaluate how they are trying to reduce the emissions. Then stock value should be evaluated fairly. So if it's the case, then we hope all clients in all supply chain, not a direct client, but the indirect client in the supply chains, they intend to go with zero emission. I think how we can create this mechanism together. And the second question, of course, we need to make a lot of collaborations, but international regulations, we are also waiting for the discussion of life cycle assessment, because people are talking about net zero or zero emission fuel, but no one knows what would be a real definition. So, which should not be only maritime industries, which should be also related to the Scope 3 accounting policy, or maybe some carbon pricing in the market somewhere, because energy is not only for marine industries, that is for other industries. Therefore, I think we are very much waiting for this kind of discussion ongoing. Thank you.
Yeah. Thank you very much. Now we went around the table and we find many common keywords based on the first round. And before go to the details or deeper in these topics, if you have, I'd like to have some questions from audiences, online or offline here in this room. And if you have any questions, could you raise your hand and ask questions to us? Not really. If you have, I think we can have some time to accept. So, if you have questions, please raise your hand anytime. Then, as for the panel discussion, we went through first round. Then I subjectively pick up several keywords, maybe, and I'll pick up several keywords which I like, aligned to the original two items. And then original two items, two discussion points are the corporate activities and cooperations, the international cooperations. Then, based on the first round, I think that I picked up two keywords. First one for corporate activities is maybe the cost for carbon neutrality and who pay the cost and how to support the first movers. Then that is, and I I'd like to have some more comments on that one, cost and first mover, how to support first mover. And that's first keyword. And the second keyword is for international cooperation. Second keyword is stakeholders, or this carbon neutrality will change the structure or change the relationship of stakeholders. I found the stakeholders, that keyword is, we hear that in this panel discussion many times. So if you have any comments on these 2 points, I'd like to have some more comments on those 2. Let me refrain that again. Stakeholder relationship and cost for the carbon neutral. Do you have any further comments on these? Policy or maybe private sectors, policy, government, anywhere, maybe have some options to support cost and first movers. Do you have any ideas on that? Thank you.
Okay, yep, thank you very much. So again, if it is a cost, and then we have 2 costs. One is CapEx, like vessel or infrastructures, and the second is OpEx, mainly for fuel cost. And party, if we make an investment or if we pay the cost, totally different. Then, but we have to say, at the end, all infrastructure, vessel, the cost should be covered by freight.
Covered by what?
Covered by freight cost. Because this is always part of freight. Then, so means at the end, end users should pay for everything. So that is, I think, key. Then, so in that sense, how we should support end users and encourage end user to take zero emission fuel vessel. I think that would be a key.
At the end, maybe let me explain my understanding. At the end, maybe 2050, everyone has to pay for that cost. But today, many people don't want to pay that cost, and we need to have some policy or subsidies to support that mechanism. But we have to accelerate that transition. Both industry must be ready, and we all the people need to used to change their mind to pay that cost and carbon neutral cost. Then that can drive the first mover and cost for the neutral. Thank you very much for your comments and ideas. Do you have any other? Oh, go ahead, please.
I think we have 2 examples in history in Japan to introduce new energy. First one is LNG, 1969 from Alaska project. At that time, caloric cost of LNG was 1.7 times more expensive as compared to crude oil. But at that time, people suffered from air pollution, and board members of electric power company concerned about energy crisis because they're heavily dependent on oil to produce electricity. So they decided to introduce LNG. But as Akama-san said, all the freight and all the cost was heaped up, and then some revenue was added on, and then people who use electricity have to pay that. It is total cost system at that time. But after that, as you know, we are getting to the free market system for the power utility companies and gas utility companies. We have to introduce such a mechanism now. And another example is feed-in type system for the photovoltaic and wind turbine deployment to the society. It is a relatively new scheme. Anyway, such a new support or gathering the money and deliver to the fast mover system is of importance. It is inevitable.
Oh, thank you for the great comments. We can learn from the history, and we experienced new technology implementation or adoption, and for that kind of environment for the environment, and maybe also we experience that and how the market respond and how to deploy or implement that new technology. Thank you very much. Then, do you have any further comments? If online panelists, if you have, just speak up maybe, and we can switch your mic on. So, do you have any comments on these topics?
I can make a couple of comments if you like.
Great. Thank you very much.
Sure. I mean, I guess in terms of how we've reached that cost gap, there's a range of mechanisms that governments can use and are using in terms of some of these technologies. I mean, one is a government subsidy in terms of grants, and we see this in hydrogen a lot, hydrogen projects. I think grants are particularly useful when you've got kind of quite new technologies that you're trying to subsidise, I guess. Governments can subsidise through other mechanisms as well, such as contract different mechanisms, and some countries are looking at those. Another, going to the last speaker's points about previous technologies and mechanisms that we've used in Australia, we've had a renewable energy target scheme for some time, and this is a scheme that allowed us to meet a renewable energy target of having 20% renewable electricity by 2020. The scheme obliged electricity retailers to buy a certain proportion of renewable electricity each year, and they pass that cost on to consumers. So I guess I'm not going to comment on which of those I think is best. It really depends on the technology you're trying to subsidise, where that technology is at in terms of its readiness levels and what the cost gap is. And there are choices and different mechanisms that you can use as to whether it's, government should subsidise that cost gap or whether we should put that cost gap on consumers. And there's different mechanisms we can use to do that. So there's my thoughts. It's not a complete answer. There's a range of mechanisms, and I think the most appropriate one does vary depending on the circumstances that you're in.
Thank you very much for sharing your information, and we got to know many types of approach to solve this cost gap. We have a question in the room, so just wait. Could you please?
Thank you very much for the good presentation. I have some comment or question that because of also I was an engineer of the automotive company who struggled to implement a new technology. For this new energy transition, there are two issues. One is new technology development, the new investment for the new technology. At the same time, you need to prepare the infrastructure. Like for marine, you need to prepare the bunkering or these kind of the fuel. But as long as I understand, so in the basically the port are prepared by normally the country. So port will not ask to the cost of the building the port. Of course, operational cost can be shared with the incoming ships. So what I'd like to say is that if you ask the final user for from the beginning of infrastructure building to the new technology, it will never happen. So because of we are faced to make the total decarbonization to some 50, you need to separate the cost of the infrastructure, which we need to share all the taxpayer or the people. Then maybe the new technology part, with this can be a discussion with the industry and the government. So when you are talking about the incentives, we have that all the industry wants all incentives from the government. That is probably some too much for the normal taxpayers. So you need to clarify the cost of decarbonization need to be shared among the whole the people and industry. It has to pay, and then they have to assist the fast mover in both. That kind of the discussion is necessary. I think that. So the question and the comments. Thank you very much.
Yeah, thank you very much your question and comments. Then maybe and thank you for the clarification of my this keyword cost and who pay the cost. Maybe and the cost is for technology development and cost for build the infrastructure as well. And then according to these comments, do you have any answers or comments or responses from the panelists? Oh, thank you. Please, please.
Thank you for your inquiry. Yeah, that's very good point. As we discussed, who bear the cost? Then it is very difficult to answer directly. And then also I mentioned governmental support, financial support is necessary. But obviously we should not rely on too much, as you mentioned. That's totally agreeable. And then currently what's going on in this shipping industry, some customer has keen interest to reduce the greenhouse gas. And then some customer is ready to bear such a cost. Not the majority, but some customer recognize if they cannot reduce the greenhouse gas, they can't survive. They cannot recognize from the societies. Such a kind of advanced customer or company, we gradually start discussion. So therefore, such type of customer, those who have interest with the greenhouse gas reduction and ready to bear some portion of cost, not all. Then gradually increase such a business area. Then eventually, so many other customers have to follow because their competitor go ahead, move ahead. Then eventually it takes time, but eventually I believe all cost, additional cost will be borne fairly for all stakeholders. That is correct, my understanding.
Thank you very much. Do you have any further responses for that comment? Oh, please.
Again, I think that is a matter of stakeholders in full value chain. So we see, if you talk about material to transport, let's say additional cost for zero emission, like a $10 per tons. But then the clients make some products based on this. Then I think the $10 per ton impact is very limited. Then their next client prepare some end products based on their products. So it means $10 impact is much less than original impact. So in that sense, we can say at the end, if we talk about the final end user is personal consumers, I think personal consumers impact is very limited. Therefore, but the key point is how how we can secure the openness among each stakeholders, because some stakeholders may consider this counterparties may take some chance to get a very substantial profit taking this opportunity. So if it is the case, it's very difficult. But that's why how we can secure that transparency or openness among stakeholders. So I think that might be a key. Thank you.
Yeah, thank you very much. Mr. Kirkby, could you comment in 30 seconds or so? Sorry, we are running out of time. So
I'll try to be very brief. I think what we need to think about here is that, yes, it is a very small impact for the consumers, and you can multiply number of consumers with a small cost, and then you can make a nice business case. You can make a nice business case here to establish the infrastructure, everything needed. But if we look at the history lesson, and I thought it was very interesting looking at LNG, and certainly we can learn a lot from LNG. But if we look at LNG in shipping for dual fuel ships, it took, let's say, 40 years from this first use of LNG as an energy source for heating until we saw it on a container ship. This means that at that time, the container ship adapted LNG as a fuel because all of the infrastructure or everything needed had been built with another, let's say, off-taker in mind. So at that time, it was cheap for shipping to adapt LNG. That is not the case today, but luckily they are dual fuel engines. They can also operate on conventional fuel. But for ammonia or hydrogen, wherever it takes us, we do not have this 40 years to wait for everyone else to let's say, create the offtake and build the infrastructure before shipping can adapt. And I think 40 years from now, we are well beyond the 2050 goals or 2030 goals set by IMO. So a lot to be learned from LNG, but also maybe something to learn from this spillover that the infrastructure actually came from other off-takers.
Yeah, thank you very much. Because of the time limitation, let me summarize this panel discussion in a few minutes. Thank you very much for your great presentations and also the great discussions. And I'm happy to have feedback from the audiences. Thank you very much. And we reviewed green innovation projects today. Then we learned the policy and technology trends and visions and status, including global partnerships of our partner countries. And also, we got the latest state-of-the-art technologies for vehicles and supply chain. Then how to deploy, implement, change the behavior of industry and society. And we find some ideas and insight and for that. Thank you very much. Then as for the discussion, we pick up two topics, corporate activities and international collaboration, international cooperation. And based on my preference, maybe, I picked up the cost and first mover problem and also stakeholder relationship. Then I got to know many ideas and many information for me to do my research work, and also I hope this will be useful and helpful for all the presenters and participants here in this room and online. Okay. Then thank you very much for joining this symposium and also the panel discussion. And I could really enjoy this time, and I hope you enjoy and make the world better and in terms of carbon neutrality. Yeah, thank you very much.
Thank you very much, Professor Hiekata and all the panelists. This is the end of the side event. We hope this symposium provided all attendees with fruitful opportunities to learn about the latest technological innovations. And as this year's meeting has been held in a hybrid format, we would like to ask all the participants to give us feedback to help us improve the next meeting. Please access the online survey on the ICEF virtual meeting website. Throughout the entirety of our side event program, we've had 7 side events. Summarizes of those lively discussions and insights for presentations will be available on our official website in due course. So please check ICEF's official website for updates accordingly. In addition, all sessions will be available on demand. Please take the advantage of these features to view the sessions that interest you. ICEF will hold its next meeting in autumn 2023 in Tokyo. Hope to see you there. Thank you very much for participating in this symposium, and see you again next year. Thank you very much.